Hello students, this is a review for Unit 5's test, which is coming up on Monday. You can see that I've underlined all of the important information in the problem. I've circled the question and I've written notes to myself. That's the annotation step. Then I created a inequality to represent the situation. That's in blue here. And then I answered the question in green. That's the contextualization step that we talked about in class. You must turn your mathematical answer back into a real world scenario. What I'm going to do in this video is I'm going to show you the model examples. I'll show you how they're done, and then I'll allow you to pause the video so you can try the checks for understanding the problem sets, and then you can check your answers when you unpause the video. Now let's move on to solving inequalities in one variable. Solving inequalities is just the same as solving equations. You need to use opposite operations to move the x value to one side and the numbers, the constants, to the other side. So what I'm going to do is I'm going to show you my steps and how to solve this inequality. You can see here that I use distributive property to take the constant that's on the outside of the parentheses and multiply it by every term that's inside the parentheses. Next thing I'm going to do is try to get all the x values, all the x terms to one side. And you can see I use the additive inverse to do that. I added 1.5x to both sides and I got 3.5x on this side, and now there's no more x term here. Now I can move all the constants to that right side. And you can see here I used additive inverse again to add 8 to both sides. I'm trying to move all the constant terms to the right hand side, and I have my x's on the left. Now I'm going to solve this problem by using multiplicative inverse. And you can see that I divided by 3.5, and I used the calculator to get this answer x is greater than or equal to 3. Last, I have to state the smallest integer value that satisfies the solution set, and I can do that using contextualization. Here I've circled the question, state the smallest integer value, and I've stated that the smallest integer value in the solution set is 3. We can see that this says x is greater than or equal to 3. That solution set would be 3, 4, 5, 6, and all of the numbers in between. And we know that integer values are values with no decimal parts. So the smallest integer value in the solution set is 3. The solution as a number line as an interval notation I will show now. And here are two other representations of x is greater than or equal to 3. This filled in circle at 3 and an arrow going towards the positive numbers. And also the interval notation showing that 3 has this square bracket representing the fact that it is part of the solution set. And infinity has this parentheses, this soft bracket as we call it, open bracket, which means that infinity isn't a number and cannot be used inside of the inequality. Take a look at the check for understanding. And I will allow you to pause the video and try it, and then I'm going to show you the correct answer. All right, here's your solution. Oh, there we go. Your solution involves a mathematical answer, the steps to the answer, a contextualization of the answer. Notice in this case it says 6 is less than x, or in other words, x has to be bigger than 6 or greater than 6. So we say the smallest integer that satisfies the solution set is 7. Notice this open circle around 6, which means that 6 cannot be used as an answer. And also notice that soft bracket, the parentheses here, which represents the fact that 6, again, cannot be used as an answer. So I'd like you guys to move on to the problem set, and I'll allow you to take a look at the problem set for a moment here, and then I will unpause the video and give you the correct answers. So here are the problems that I'd like you to do. Pause the video now. Here are the first two answers. You can see that we solved both inequalities, same as an equation. However, this inequality we divided by a negative, so we had to change the inequality. We changed it from greater than to less than. The interval notations are here, and both of them represent an approach to infinity or negative infinity, respectively, and both of them have that open circle because there is no underline for the inequality. Now let's move on to questions 3 and 4. Pause the video now, and then you can take a look at the answer in a moment. Here are problems number 3 and 4. I've written the interval notation, I've solved the problems, and I've graphed them on the number lines. Take into account the fact that in this case and in this case we divided by a negative number, so we switched from less than to greater than, and from less than or equal to greater than or equal to, respectively. Another change is this soft bracket for -6 because we have no equal sign, but now there's a hard bracket here, that square bracket at 9. That should be -9. Thanks for pointing that out, Mr. Sporting. That -9 is involved in the solution set. Take a look at numbers 5, 6, 7, 8. I'll give all of those answers at the same time. So try them out and pause the video, and I will show you the answers in a moment. Here you can see the answers to 5, 6, 7, and 8. I've graphed all of the answers as inequalities on number lines. I've solved the inequalities, and I've also given you interval notations. For number 9, it asks you to solve algebraically and state whether the number is in the interval 4 and 8. These hard brackets, these square brackets, indicate that 4 and 8 are answers. So what we're first going to do is solve the inequality algebraically. That's our first objective. We're also going to state all the integers that satisfy the given inequality. So that's the thing that it's asking us to do. So we'll circle that. Whoa. Circle's way off. So pause the video now, try to solve algebraically, and try to determine which of the solutions here are part of the interval from 4 to 8 inclusive. I'll try to show this one in stages because it's a little bit more involved. This first step is 7x minus 3 times 4x minus 8 is less than 6x plus 12 minus 9x. That part was given. Here I've distributed that negative 3 times 4x to give you negative 12x, and negative 3 times negative 8 to give us positive 24. I haven't done anything to the right side of the inequality just yet. My next step was to combine like terms. I've combined 7x and negative 12x. I've combined 6x and negative 9x. So now I'm going to be a little strategic. I'm going to add 5x to both sides. I could have added 3x to both sides, but the reason I want to do that is because I want my x value to be positive. Here I've added 5x to both sides, and now I have 2x, a positive coefficient of x, plus 12. Now I'm going to subtract 12 from both sides, and the end is in sight here. I see that 12 is less than 2x, so I'm going to divide both sides by 2 in order to get my answer of 6 is less than x. Now I'm going to graph my solutions on the number line and try to determine which integers satisfy the given inequality. Here's where you need to interpret the problem a little bit. It says that x is greater than 6. So the values of x can be anything above 6. So 6.01, 6.5, 7, 8, 100, 1,000, whatever you want to use. This says that x is a number in the interval from 4 to 8 inclusive, which means that x is somewhere between 4 and 8, and you can use 4 and you can use 8. If it's asking for all integers that satisfy the given inequality, there are only a few of them that do that. One of those integers is 6. Oh, I'm sorry, not 6, 7. We say 7 is one of the answers because it is an integer in between 4 and 8, and it is also in this solution set. Another one of those integers is 8, because we are allowed to use 8 in our answer set. It says here that 4 and 8 is our interval, and 8 is the largest number, and it is included in the interval. So our two answers, the two numbers that satisfy the given inequality and are between 4 and 8, our two answers are 7 and 8. We don't use 9, even though this arrow indicates that it's going on forever towards infinity, because x is a number in the interval from 4 to 8. It does not include 9, 10, etc. So our answer should be 7 and 8. So if we were to write out an answer for it, it would look like this. The integers in the solution set are 7 and 8. We're going to move on to the next page of the review. Now I've done the model example for you, and it does say that it's looking for the value of x that's in the solution set to the inequality. I divided by a negative here, so I got a flipped sign. It went from greater than to less than, and I see that it says x is less than negative 3. Be careful, because the answer is not any of these answers that are here. It's this last answer, because the only value here that is less than negative 3 is negative 4. Often they'll give you a choice of negative 3 or negative 4, and this negative 3 does seem like it's the answer, but it says that x has to be smaller than negative 3, so negative 4 is my only answer. Try the check for understanding. You can pause the video now, and I will show you the correct answer in a moment. Here's another example of the math problem trying to trick you. You've gotten the solution that says x is less than 14. Now 14 seems to be the viable answer here, but wait, x has to be less than 14, so it can't be equal to 14. Your correct answer then must be 13. Let's move on to the problem set. I'm going to ask you to try these first 4 problems, pause the video, and then I will give you the correct answers in a moment. And you can see that in all of these examples, it's asking for numbers that are less than or greater than the given value. So we can't use that given value. We can't use -3, for example. We have to use the value that is less than -3, which is -4. Move on to the next 4 problems. In these 2 problems, keep in mind that in this one, we're using a greater than or equal to symbol. So we are not going to change the number. We're just going to use that same exact number. So pause the video now. I'll give you the answers to these 2 before we move on to the longer problems. It gives us that x is less than or equal to -2. -2 would have been a viable answer. Since -2 is not here, though, we're not going to choose it. We are going to choose the smaller value than -2, which is -3. And same thing here. X is less than -2, so we're going to use -4, not -2, because we're using less than, not less than or equal to. Next, it gives you the fact that x is equal to -1. We're going to substitute in -1 here, and we're going to determine the largest integer value of a. Now, this answer might seem a little strange, but follow me here. We've substituted in -1. We multiply it through. We get the value of a by itself, and it says a is less than -19. We're looking for the largest possible integer value of a. Well, if a must be less than -19, it could be -20 or -21 or -22 or -100, but the largest possible integer value of a is going to be -20. It's the first integer that you come up to once you go below -19. Next, we're going to try to do that last problem in the problem set. Pause the video now. For this next problem, we solved pretty normally, except we didn't move the x values at the beginning. We isolated this x value, the 2/3 x, because I wanted to use what's called the reciprocal to get rid of or eliminate this 2/3. Once I got 2/3 x on this side by itself, I multiplied both sides by 3/2. It's reciprocal when you flip it upside down. Once you multiply by a reciprocal, this 2/3 and this 3/2 multiply out to become 1, so we don't need that anymore. Then 3/2 times -2 gives us -3, and 3/2 times -10 gives us -15. The calculator can tell you that. Once we get the x value by itself at the end, it's -3.75, and now we have to contextualize. We know that the values of x have to be less than -3.75. Well, these positive numbers won't work, and this -3 is greater than -3.75. The only number that's in the solution to the inequality is -12, because -12 is less than -3.75. Let's move on to the next page. I'll do the model example for you, and then I'll let you do the problem set. In this case, all we had to do was solve both inequalities, and we got x is less than 1, or x is greater than 6. If you remember from your studies of graphs of inequalities, you will remember that or usually means it is a divergent inequality, the lines split apart. Now do the check for understanding. Pause the video so that you don't see the correct answer until you're ready. Here you can see that we solved both inequalities. This inequality sign had to flip because we divided by -3. Both of them are put together with the word "and" in the middle. Now move on to the problem set. I'm going to allow you to do the first 3 problems. Pause the video now, and I will show you the answers in a moment. All right, I want you to notice that in both of these first 2 inequalities, we've represented an "and" inequality in which they are convergent. For this inequality, there's no answer. Think about it. X is greater than 5, and also x is less than -1. There's no x value that satisfies both of those conditions, so we leave it blank. Take a look at the next 3 exercises. Pause the video now so that you can try it out and then check your answers in a moment. The first 2 are pretty straightforward divergent inequalities. We have the arrows that are moving away from each other, and we have a gap in between. This last one says x is greater than -6 or x is less than -3. Thinking about it logically, it should mean that all of your values are possible. There is no value that is impossible here. So we're representing it as shading in the entire number line. Take a look at the next 2, and this will be the last exercise. Pause the video. So you should see the solutions to the inequalities are here, the graph is here, and the interval notation is here. Same thing here, the solutions are present, and you can see that OR is a split inequality, and the graph is here. Good luck studying.